Hello, this is Frank Allen at Davis High School. This is another lesson in the Unit 3 set of lessons for Unit 3 in chemistry. This lesson is going to cover electron patterns, or as it's probably better known, electron configuration. Basically, you have to be able to take this, which we will give you for the test or the quiz, and fill it in appropriately with electrons from whichever element we give you. Most of the time we make you have to memorize this order, but we've decided to simply give you this order. You also have to be able to answer some other questions about what these symbols mean, but we're not going to do that. We're going to teach it a little bit more simplistically. Now, the numbers and the letters simply represent areas within an atom where electrons exist. Think of them as rooms inside a house. The first floor has an S room. The second floor has an S room. Also, the second floor has a P room, and so on and so forth. And again, you don't have to know how we got this. You don't have to memorize it. You just have to know that each one of these numbers and letters together sort of represents an area within an atom where we probably find an electron. You do have to memorize, however, that your S rooms can hold at most 2 electrons. Your P rooms can hold at most 6 electrons. And your D rooms can hold at most 10 electrons. Now, when we give you an element to fill out the electron pattern for, you have to know how to fill this out. So you know that whatever the S room is, it can only hold 2 electrons. The P rooms can hold 6 and the D rooms can hold 10. You also have to know that you can't use this room until this room is full. You can't use this room until this room is full. So in other words, you have to fill up each room before you use the next room. You can put 6 in here. You don't have to put 6 in here, but you can't use this until there are 6 in here and these rooms are also full. So let's do a couple of examples. Let's say that we give you sodium. So sodium, you look on the periodic table, sodium has 11 electrons. So where do they go? Well, the S rooms can hold at most 2, but we have to fill this up before we use the next room. And so we put the numbers up here sort of like a superscript. This isn't an exponent. It doesn't mean 2s squared. It means that there are 2 electrons in this area. There are 2 electrons in this area. And the P room can hold 6. Now, are we going to have to put 6 in here? Well, 2 and 2 is 4. We can only put 6 in here. That would be 10. So we're going to have to use this one right here. So we do have to go ahead and put 6 electrons in there. And then we're going to put 1 right there. We can put up to 2, but we only need to put 1 because these add up to be 11. Magnesium. It has 12 electrons. Well, we're going to put 2 in here, 2 in here, 6 in there, and then 2 in there. And I encourage you to hit the pause button once I write an element down, and then you try it yourself, and then you can go back and check it. So let's take a look at oxygen. 8 electrons, and you get all these from the periodic table. You don't have to memorize it. You always have the periodic table in front of you. So 8 electrons, where are they going to go? Well, we can put 2 in that room. And we can put 2 in that room. And we have to, because in order to use this room has to be full. We can put up to 6, but we only need to put 4 because we're only trying to show 8 electrons. So this room is actually not full. So it's got space available for 2 more electrons if we needed it. So you might be asked to fill out an electron pattern. We'd give you an element and ask you to fill out the electron pattern, and we'll give you this and you have to fill it out. Another question that you might be asked is, what element ends with, and then we'll give you some aspect of this. So let's say what element ends with 2p3. Okay. Well, if it ends with 2p3, that means that these are all full. That means there's 3 in here, but these are all full. So if this has 3 in it, that means this must have 2 and this must have 2. So that's a total of 2 and 2 is 4, 3 is 7, 7 electrons. You look on the periodic table, that's nitrogen. Or if it ends with, let's say it ends with 3d6. So that means there's 6 electrons in here. Everything else has to be full. That's 2 electrons, 6 electrons, 2 electrons, 6 electrons, 2 and 2. So if it ends with 6, that's going to be 6 in here, 2 is 8, 6 is 14, 2 is 16, 6 is 22, 2 is 24, 2 is 26 electrons. If you look on the periodic table, 26 corresponds to good old iron. So if you can answer those types of questions for electron patterns, electron configuration, then you've mastered this concept of Unit 3. Go on to the next concept.